Welcome, everyone. Having a good conference so far, I hope. I did want to lock the doors to make it a real escape room, but apparently that's dangerous, something about a fire hazard. So you're just going to have to bear with me. My name is William Brander. I work for a company called Particular Software. We've got a booth outside. I'm not talking about anything to do with Particular Software today. In fact, today I'm talking about my crippling addiction to escape rooms. I love escape rooms, and every time I go and travel somewhere, I try and find an escape room that I can do. In fact, yesterday I did one in Chelsea. It was a zombie-themed one. It was fantastic. But every time I go somewhere, I look for an escape room I can do because they are so much fun for me. In fact, I've done an escape room on 6 out of the 7 continents. The only one I haven't done is Antarctica, which is a bit of a problem because there are no escape rooms there. Really messes my completionist mindset. However, I've come up with 2 plans to solve this problem, and we'll see which one works out for me. The first is destroy Antarctica. There's a talk about nuclear energy a little bit later. Hopefully, I'll get some ideas there. The second approach is to completely change careers and become a research scientist, because there are these research stations on Antarctica. And what I will do is, as soon as I get accepted and I become a research scientist based in Antarctica, I will make sure that I take all the keys and access control mechanisms I can find, throw them outside, thereby triggering a forced escape room with my new colleagues who are definitely going to love it. It's going to be a good time for everyone. I come from South Africa, and South Africa does have a research station on Antarctica, but I wouldn't do it there. This is the Norwegian one, which is where I would do this. And that's predominantly because this is known as the troll station. And I think that's the best place to act like a complete idiot. Another fun fact about the Norwegian research station is that they've got their own time standard, because being in Antarctica means that the date timelines don't really make sense there. So the time standard for the Norwegian research station is called troll time, which is great again. So those are my 2 plans for Antarctica. We'll see how that works out. Now you might be asking yourself, well, William, why would you build your own escape room? And that is a really good question, because it was way more work than I thought it was going to be. But I did it for these 2 young ladies. These are my daughters, and I absolutely adore them. And they know that I love doing escape rooms, so they asked if we could do an escape room together. Now, in Johannesburg, unfortunately, there aren't any escape rooms that are of a suitable level of difficulty for children to do. I saw there was one at the Chelsea escape room yesterday for children, but in Johannesburg, there aren't any. They wouldn't have a good time. They wouldn't be engaged with the puzzles. It would be boring for them. And I don't want them to do an escape room and not enjoy it, so I thought maybe there's a way that I can come up with an escape room that they can do with their friends so that they can also begin to get a love for building escape rooms. So that's why I decided to build my own escape room. And what I wanted to do is I first started identifying what I liked about escape rooms so that I could take those things that I liked and put them into the escape room for my children. And the first thing that I like about escape rooms is the decor is typically very specific. Like, this is very clearly an escape room type scenario we've got here. There are little padlocks that you can't really see hidden around the room. There's weird quotes on the wall. The one there says, "Hell hath no fury like a woman scorned." That's great for an escape room. If this was your decor in your house, please come and talk to me afterwards, because I bet you're really interesting. But it's very specific niche themes. The rooms in the escape rooms are very typical. You know that you're in an escape room. So I wanted that sort of feeling for my children. The next thing I wanted is, if I couldn't do lots of different rooms, because I wanted this to be portable, I wanted to be able to have multiple chests that the children had to open, multiple boxes. There's nothing better than when you complete an escape room and you open the door and you think you're finally exiting, and then you've got an entire new room with new puzzles that you get to explore. It's great, and I wanted my children to be able to experience that as well. The types of puzzles must be stimulating for the children. They must think that, wow, this is really cool. Why are these bottles green? Does it matter that some of the contents are a little bit different? I want to stimulate their imagination whenever they get to a new set of puzzles. And then I obviously wanted the escape room to be completable or finishable. And this one is a little bit tricky, because you don't want an escape room to be finished in 20 minutes. That's too easy. You haven't been engaged with the room yet. You want it to be finished somewhere between a 45-minute and 60-minute period. In fact, some of my favorite escape rooms are the ones where you can see the clock on the wall and it's ticking down. It's 59 minutes and 40 seconds, and you've got 20 seconds left, and you solve that last clue, and you have to sprint across to get to the main door. I live for that. That is great. So I wanted the escape rooms to be finishable for children. At this point, it gave me like a reasonable set of requirements that I had. So the first thing I wanted simple puzzles, because the children need to be able to know how to interact with these. Now, I don't mean simple is easy. Easy and simple are different things. As an example, if you're pushing a button, there's a button that you have to push. That is simple and easy to do, but if you hide that button away behind laser tripwires, it's still simple, but it's a bit harder to be able to do. I also wanted the escape room to be finishable, and again, not just completable. I wanted it to be done within that 45-minute to 60-minute sweet spot. I wanted lots of different areas so that the children would solve something, then move off to something else and open another set of puzzles there and get a whole new experience every time they open something. And then all of the puzzles had to give the children a sense of wonder. They must be stimulated by what they're being presented with. And this because it was a lot of work to do this, I wasn't just going to do this once off. So I also wanted some level of replayability so that I could run this escape room multiple times for the children and they wouldn't get bored. Which also means that some of the puzzles need to be reconfigurable. So I wanted to be able to use puzzles in slightly different ways. Out of all of these requirements, the hardest one by far was that the escape room must be finishable. Because we've all been children. Some children are really smart. Some children are, well, maybe we don't know in which ways they're smart yet. And designing an escape room that they can finish within a 45-minute to 60-minute period is really difficult because you don't know which level of smartness you're getting on the children on that day. It depends on how much sugar they've had, how they've been sleeping. It's very difficult to do. So what I eventually settled on is that I wanted the difficulty of my escape room to change automatically. So if the children were going a little bit slower through the puzzles, the following puzzles must be made a little bit easier. Or if they were going very quickly through it, the follow-up puzzles must be made a little bit harder. So the difficulty of the escape room must scale with how quickly the children are working through the escape room. Now, I want to show you a few of the puzzles that I used, and we'll see like a few examples of how the difficulty is able to change for those. And then we'll start getting into the actual software development part of this. So there's just a little bit more context here. The first puzzle is one that I call a balance puzzle. There's a little digital spirit level inside, and it just determines whether or not the device is being held perfectly flat. Or you can also configure this one to have to point at specific targets within a room. So you can have like numbers written around the wall, and if they're pointed to the number 8, it'll light up to say this is a correct number that you're supposed to be using. The difficulty of this can be changed by how close it must point to the target. So how perfectly level it must be before it unlocks the next part of the puzzle. You can also change how long it must be on the target, and then how you interact with this puzzle. So if you're holding it in your hands, it's a lot easier to get fine control over where it's pointing, whereas when the children do this, they typically do it with strings attached to it. When I run this for older people or adults, there's levers that I attach, so they've got indirect manipulation of it. Obviously, those are things that you can't change while the room is busy playing. But you can decide, like, these people that are playing my room are relatively dexterous, so I can make it a little bit harder for them at the start. And then, so that's how it's manipulated, and the number of targets it has to point at before it realizes you've opened the room or solved the puzzle. The next one is a musical tone. This one is fantastic because children, so what happens is there's a little button at the top, you push the button and it plays a tune, plays a little song out of a speaker there. Then there's a keypad, and each number on the keypad corresponds to a musical note. So they need to replay the same song that the speaker's playing. This one is really good for children to do because they're silent for once, while they're all sitting listening around to this tune that they're busy playing. You can change the difficulty of this by changing the length of the song that they have to play. So if it's Happy Birthday, the first chorus of Happy Birthday is maybe sufficient, but if you want to make it more difficult, you can choose a longer song along the way. The randomness of the song, so if the children know the song that's being played, it's easier for them to keep track of that, and they can then use their inner ear to listen and think, okay, now it's going to be this button next. Whereas if it's a song they don't know, it's a lot harder for them to be able to do that. So for this one, if they are going through the escape room really quickly, the harder song is the Tetris theme song, because most children don't really know the Tetris theme song anymore. But if it needs to be easier, then it switches to the Super Mario theme, because even my children know the Super Mario theme. This puzzle is something that I call Simon Said. It's multiple boxes. I eventually made 5 of them, and they've got 2 lights on and 2 buttons. And what happens is the lights flash in a different order across the different devices, and the players have to repeat that same pattern that the lights were flashing. This one is also really great to see children do, because if one child gets it wrong, everybody loses their mind, and they pile into that poor child. It's a little bit of karma. It's really, really fun to do. You can change the difficulty of this by changing the number of devices that are involved in the pattern. So if you're using all 5 devices, each child has to coordinate with 4 other children to remember the order that they have to push in. Whereas if you're only using 2 devices, it's substantially easier for the children to be able to do. You can change the number of buttons. Now, obviously, I don't mean physically take the buttons out while they're busy playing the game, but if you're only using the left button, it's also easier for the children to be able to remember the pattern, rather than if they have to remember both buttons at different orders. The length of the password that they have to repeat also changes the difficulty of this. So there's a lot of different levers for all these puzzles that you can change the difficulty as the children are going through the escape room. Once they've solved some of these puzzles, you need a way to dispense the next set of clues. So a few examples of those: simple maglock with a box. Once they solve a puzzle, open it up, and whatever's inside will fall out. This one's classic. Little treasure chests also seem to get their attention. Pro tip, children are destructive little gremlins. So if you don't tell them, don't force this open, and they walk in the room and they see this, the very first thing they are going to do is go, oh, what's this? Strip it open, and then the puzzle won't work when it's supposed to. Another one that children quite enjoy is what I call a sword in the sheath. So there's a little maglock again on the sword, and it produces just enough magnetic shear tension to stop the sword from being pulled out easily. My wife was not happy that I put this in, but the kids absolutely love it. And then by far, my favorite way of dispensing clues is something that I call loud noises and splinters. It looks like shit. My wife says I have a very prototype aesthetic. She's been very generous there, because this actually is just atrocious. But this one is super fun, because if you can hide this away where the children don't see where it is, when you solve the clue that triggers this, there's a little servo at the back, and that disengages, which then allows the whole thing to slam forward and throws whatever you've put in the top across the room. So if you hide it and they don't know it's there, they typically get a nice fright, especially if you've got them doing the music one and they're all very quiet. And then all of a sudden, bang, and this thing comes flying across the room. I like to think that I'm teaching the children that progress is scary and they should be afraid of advancing towards their goals. Now, all of these devices have something in common, and that's the devices that I use to communicate with these and program with them. This is an ESP8266. There's a variety of these options available out there. Essentially, what these are little computers that you can program on. So you might, for instance, have a web server. And in this case, when you get a request to the root URL, just respond with 200 OK, for instance. So you can program little web servers on these devices, and then you can communicate with them via HTTP requests. The problem here, though, is that this is single-threaded. So what happens is there's a loop method that just iterates over and over and over and over and over and over and over again, and you call server.handleClient. So that code goes and says, well, is there an HTTP request I need to respond to? If there is, it can send a response. If there isn't, then it moves on and does whatever else it's supposed to do. This works fine, except it's single-threaded, which means that if you're doing something else, you potentially aren't going to respond in the time that you should. An example of this is, if we've got a device and it gets an HTTP request, the device says, oh, OK, cool, I need to do this. I need to unlock the box, for instance. So I disable my maglock, and the box opens, and I give the HTTP response back. In the happy path, everything's fine, because that's exactly what it was supposed to do. But what if instead we had another chip connected to this device? So this is one of those digital spirit levels. It's an MPU 6050. And some of these devices have got digital motion processing built onto the chip, and some of them don't. There's a bunch of counterfeit devices that don't, and if they don't, you only know once you've actually tried to communicate with it. And if you have to do that yourself, it could take a long time to do the digital motion processing. So if this device was busy calculating the angle that it's pointing at in three-dimensional space, while it's busy doing this, if an HTTP request comes in, it might take a really long time to work out what that angle is. And in the meantime, before it's gone and worked out what the angle is, that HTTP request could time out. So we've got temporal coupling between the devices and the requests that we're making. If we make the request at the right time, we'll get a response. But if we happen to make the request at the wrong time, we won't get a response. A better approach would be if we've got the devices and they're busy working out what the angle is. So the device is calculating the angle. It's taking a really long time, whatever. By the time it finishes, it should go and check, hey, is there something I need to do? Do I need to tell someone to do something? Do I need to open a box? What is the next step along the way? And this you can do, you can have a file somewhere that you can see, well, these are the things I need to do, or because I work for particular, we do distributed systems, queuing is a natural fit for me. So using something like MQTT, which is a broker that works really well with these IoT devices, was a natural fit. So what would happen is once it's done calculating the angle, it can then go and say, is there a message on the queue that I need to take off and process? If there is, I will do that. If there isn't, I'll move on. MQTT is nice because it's lightweight, it's reliable, you can do at most once delivery, at least once delivery and exactly once delivery of messages. In theory, that's a bit of a lie. We'll get to why that's a lie just now. And it's standards-based, which means that if you're doing your broker using Mosquito, for instance, you could at some point switch to a cloud broker without any massive changes because the standards should just work across all of the implementations. There are a few downsides to MQTT, though. The first is it's not actually a queue. Even though it's got queue in the name, it's a filthy, dirty liar. What I mean by this is that you can only ever have 0 or 1 messages in a MQTT topic. You can't have 2. So if there's a message in a topic already and you send another message to that topic, guess what? That first message disappears. So I like how they say you can get exactly once delivery, but they can't even guarantee that the messages stay in the queue for the duration that it needs to. And it's got a slightly smaller feature set than some other brokers like RabbitMQ or Azure Service Bus or something like that. We will circle back and see how I worked around some of these limitations a little bit later, because some of these were a bit difficult to work with. So I had all these devices, and they're communicating via Mosquito, which was the version of MQTT that I was working with. And they were publishing and subscribing messages with each other. So that's all the context. Now we're going to get into what I learned along the way. So there's 4 things specifically that we're going to cover. We're going to cover monitoring, so how I monitored the devices in this escape room. Then we're going to take a look at aggregate routes and what I learned about aggregate routes in bounded context. How I was able to change the flow of the escape room depending on how the children were progressing through the escape room, and then how to work around the limitations of some of these low-power devices and MQTT specifically. So when I started with this, I wanted to monitor the devices because I needed to know if they were up and if it was working the way that it was supposed to. So the first thing I did is, well, I need to monitor if there's any failures. So a lot of these devices, if something goes wrong, they just reboot, which means that when the device turns on, you need to go and find out, why did you reboot? Why are you starting up? Did you lose power? Was it a hardware fault? Were you taking too long to handle back to the main thread, so you thought something was stuck, so you reset because of a watchdog timer? Whatever the reason, you need to go and check, well, why did you reset? And then after you find that reason, then send a notification to me so that I know, look, this device is having a hardware failure. It might not be working while they're doing the escape room. Then I also added health check APIs. So that's just if you've got a API/heartbeat, return a 200 OK, so that another external process could go and check, are all of my devices working? And then I started thinking, well, I can also look at queue length. That might be a nice metric to look at. And at this stage, I took a step back because this was reminding me of how I monitored systems in the mid-2000s. It was very low level. I'm doing very specific things here. So maybe this wasn't the way to work. Now, some of you might be old enough to remember, but in the mid-2000s, systems were a lot easier. We've come up with a very complicated way to render HTML or to send HTML down to browsers. Back in those days, you would just have a system that could maybe talk to a database. If you were really fancy, you might have an application server somewhere in the middle as well. But all you had to do to monitor this was to ask yourself 3 questions. Is my web server up? Is my database server up? And can my web server talk to the database server? We've come a long way since this, because this, that's not really how we monitor systems anymore. And because I work for Particular, I spend a lot of time thinking about how to know whether distributed systems are working correctly, how you monitor distributed systems. So I took some lessons from that space and applied it to the escape room devices. Now, when you're monitoring distributed systems, there are 3 different attributes of monitoring that you need to be aware of. The first attribute is the area that you are monitoring within your system. So what do I mean by this? Well, the area of your systems that you can monitor is you can monitor the infrastructure of your system, you can monitor the application or the applications that comprise your system, and you can monitor the capabilities that those applications expose. Some example questions to make this a little more concrete is you might ask, are my devices online? That's looking at the infrastructure of my escape room system. Are my devices responding to publishers? Is looking at the application level of my system. And can players solve the puzzles would be looking at the capability, the actual functionality that the system is exposing. So that depending on the type of question you ask, you are looking at a different area of your system that you're monitoring. To go alongside with this, there's also another attribute called the concern that you're looking at. So the monitoring concern is where you would ask things like, well, what is the health of my system? Now, in this case, you would ask, there would be a many-to-many relationship between the monitoring area and the monitoring concern. So you could monitor the health of your infrastructure, you could monitor the health of your application and the health of your capability. The next level up from this is looking at the performance of your infrastructure, application, and capability. So is my application performing the way that it should? And do I have capacity? What is the capacity of my infrastructure? What is the capacity of my application? What is the capacity of the capabilities? Do I need to scale something up? The third attribute is how you interact with this monitoring system. So do you just look at the dashboard every now and then? That would be passive interaction with your monitoring tool. Perhaps once the monitoring tool picks up that something might be happening, if it automatically sends a notification to you, that would be looking at reactive monitoring of your system, because it could tell you something is happening here, you might want to take a moment to see if you could address something. And then proactive monitoring is where your monitoring system would attempt to auto-repair something that's gone wrong. So potentially scale up additional instances if the queue length is growing particularly long. So let's take a look at what I was monitoring with those health check APIs. The health check API was just telling me that the device was responding to an HTTP request and it was sending 200 OK back. So that is looking at the health of the infrastructure passively, because I just looked at it every now and then when something wasn't working the way that it was supposed to. MQTT queue length was also looking at the health of my infrastructure, because the queue length in MQTT can only be 0 or 1. I knew that if the queue length stayed 1 for a really long time, there's a likelihood that my devices were not taking messages off of that queue. So there's an indication that something could be wrong. But in this case, I'm monitoring the same thing, or I'm getting the same area and concern as with the health check APIs. And in fact, the health check APIs were giving me false positives, because they were returning 200 OKs when I was making that HTTP request, but the MQTT client I was using had silently decided to fail. So it was responding to HTTP requests, but it wasn't taking messages off the queue to do what it was supposed to. And using this rubric to go and identify what you're monitoring with each of these tools is a way for you to be able to say, well, this is duplicate information. And if you're monitoring distributed systems in production, you can get a lot of information. And using something like this is a great way to be able to say, OK, this is actually important, or this isn't that important. When I was looking at the failures, that was a reactive look at the health of my infrastructure. Again, very similar to what I was getting with the health check APIs and the MQTT queue length. I wasn't necessarily getting much new information by looking at failures. If I had canary devices, so that would be, I've got maybe a backup set of all the puzzles, and while the children are busy solving the puzzles over there, I'll sit this side and I'll go through the puzzles on my own. That would be looking proactively at the health of the capability. So that's actually looking at what the children are going to go through with the escape room and how they're going to solve the puzzles. Some more real-world examples of the way this can be helpful is if you're looking at queue length, not MQTT queue length, a real broker, so maybe you're looking at RabbitMQ queue length or Azure Service Bus queue length, that would give you a view into the performance of your infrastructure. So is my queue length growing or is it contracting? It should tell you whether or not your application is coping with the performance requirements that you have. But queue length on its own isn't really a useful metric because it just tells you, hey, I've got 1,000 messages in my queue. Is that good? Is that bad? I don't know. It doesn't really tell you much. So another metric you can look at is the processing time of the messages. So as you take a message off of the queue, the processing time is how long it takes you to process that message. If you've got 1,000 messages in your queue, but they only take a few milliseconds to process, that's probably fine. But if you've got 5 messages in your queue and each one takes 5 minutes to process, that might not be fine. So the processing time can be sometimes more helpful than just the queue length on its own. Another attribute you can look at is a metric known as the critical time. So the critical time of a message is, as soon as I send the message, a stopwatch starts counting. And that critical time only ends once the message has been delivered to the destination and has been successfully processed. So the critical time includes time spent waiting in the queue, it includes the network latency time, and it includes how long it takes to process the messages. So eventually, you can start having a feeling for what the critical time of your system is, and you can start seeing, well, why is the trend of critical time increasing? That's a potential problem. And then, of course, you can do something like look at the queue length and decide whether or not you want to scale up or down instances. So that would be proactive monitoring, an example of proactive monitoring of the performance of your infrastructure. So when you monitor distributed systems, it can be helpful to think of these different attributes of what you're monitoring and see if you are doing duplicate work. And perhaps there's ways you can combine other elements to give you the same information, but with less work that you have to do along the way. So that was how I monitored the system. Let's take a look at aggregate routes. Now, the music box, or the music tone, is a nice puzzle to talk about aggregate routes because it's self-contained. It's one physical device, and you can reason that this device is its own thing. For instance, all of the logic is completely self-contained within the device physically. The internal logic of the device can change completely, and none of the other puzzles in the escape room need to know that something has happened. All that this needs to do is publish when it's been solved, to publish a message to say, hey, players have successfully solved this thing. And it only needs to subscribe to difficulty changes. If the escape room must be a little bit easier, it just subscribes to the difficulty and then makes its own little changes. In this example, the service boundary of this puzzle is very well defined, and it matches the physical deployment model as well. But if we take a look at, for instance, the Simon Says puzzle, this one is a little bit harder to reason about because you've got 3 physical devices, or somewhere between 2 and 5 physical devices that form part of one puzzle. If there's another system that controls the difficulty and it says, well, the difficulty is now 5, that message goes to MQTT and then it goes to where? Because each of these devices aren't a puzzle on their own. They need to work together to be a complete puzzle. And what actually, instead of using MQTT for these devices, what I ended up doing was, when these devices start up, it uses UDP broadcast to nominate one of these devices as a primary device. All the others were secondary. They would set up a peer-to-peer network between them. This is using ESP now, which is like a weird little Wi-Fi 2.4 gigahertz format. It's like UDP almost. And then only the primary device has to subscribe to MQTT, which means that if we send a difficulty change message, it goes to the primary device, and the primary device says to all the secondary devices, okay, everyone, the difficulty is now 5. That means the pattern is going to be me, you, me, you. So the primary decides that. But what this ultimately means is that all of these devices together comprise one logical puzzle. So even if they are physically separate, the code is deployed physically in multiple locations. Logically, it's only one puzzle. And if something goes wrong with the primary device and it collapses for whatever reason, one of the other remaining devices could assume the role of primary and then create a new network between the remaining devices and subscribe again to MQTT. So ultimately, all of these devices together comprise of one logical service boundary. So even if they are physically deployed to different locations, logically it's one puzzle that's involved. And that works even when it comes to business systems, which we'll look at a little bit later. So in this case, if you've got the logic distributed across these 3 devices, the logic is self-contained, even though it's physically in separate locations. The logic within the service boundary of all of these can change. Only the primary has to publish when the puzzle has been solved, and only the primary needs to subscribe. So in this case, the service boundary is broader than just a single deployment location, but it is still a service boundary that comprises all 3. Some other examples is if you're doing an e-commerce site, maybe you've got a stock service and the user is trying to delete an item from the stock database. The stock service, if it has to go to a user service and say, does the user have permission to delete this entry? This means that the stock service doesn't have all of the information it needs to make a decision. It needs to cross a service boundary to ask something else. And in this case, it might not be particularly good. So if the user service says yes, they do have permission, and the stock service deletes it, this is a sign that the logic is not self-contained. The stock service needs additional information in order to make decisions. The service boundaries in this case could be poorly defined. I'm not saying they are, but this is a clue that perhaps there's something with your service boundaries that you need to rethink about and decide whether or not they actually make sense. Some other examples, maybe if you're in the insurance space, you're busy processing a claim payment, and the claim service has to ask the payment service, hey, has the user paid all of their premiums? Are they up to date? In this case, the claim service needs information from an external service boundary. So the service boundaries in this case may not be well defined. Or if you're placing an order on an e-commerce site, and the order service needs to ask the stock service, hey, do we have stock of this item that I need to ship? Again, these are examples of where you're crossing service boundaries, and potentially you may want to rethink those service boundaries. Now, if you have to cross service boundaries, well, the obvious solution is just to make your service boundaries bigger, right? So include the stock service in the order service. And sure, that's a choice you can make in life. But another option that isn't really talked about very often is making those service boundaries smaller. So if you shrink them down, you can sometimes get away with a lot more freedom. So instead of having a stock service that deals with both deletion and addition of stock and managing inventory counts, if you only have a service whose only function is to remove items from the stock registry, by virtue of the fact that somebody has got access to send a message to that topic means that they have got access to remove items. And in this example, by making your service boundary smaller, you've simplified the problem there. If there's only one place, or if there's only one function that a service boundary provides, it means that a lot of the work you have to do becomes easier to reason with. So by virtue of the fact that you've got access to be able to publish messages to this queue, you know that the user already has access to delete items. It doesn't need to ask, does this user have permissions? That becomes an infrastructure concern, not an application level concern. And the key thing here is there's a difference between verbs and nouns. So stock removal is you're doing something. Stock is just a generic attribute. And if you can get your service boundaries small enough that each of the boundaries are around a specific operation that you're doing, it means that you can sometimes get away with having smaller service boundaries and having permissions or having infrastructure reflect problems that you have to work with. So in this case, the stock removal service only knows what it has to. If there was another service, maybe, or another business rule that maybe you can delete items only up to £5,000 in value, then you could have a second service that actually approves the removal of items. So as soon as you remove it in the one, it sends a message to the approval. Someone who's got access to read messages off of that queue will be able to get the message and either approve or deny it. Again, by making those service boundaries smaller, you focus on what they're supposed to do. And the important thing is that your service boundaries are business rules, and you should embrace them rather than trying to hide them away. You may ask yourself, well, if we shrink everything down, doesn't that sort of limit how we get these systems to talk together and how they interact with each other? Yes, but no, and we'll cover that next. So we'll take a look at managing the escape room flow. Now, all of these devices are sitting and they're communicating with each other via MQTT, and when I started trying to make the difficulty scale automatically, I only had 1 or 2 devices at that stage. So what would happen is I'd start the escape room. Each device would then say, well, it's now been 5 minutes and they haven't solved me yet, so maybe I need to make it a little bit easier. And that worked okay for 1 or 2 devices. You could change the difficulty based on how long it was taking. But then when you start adding more puzzles in, each of those puzzles have got their own little timer and their own little difficulty that they need to track. So if it's taken 5 minutes to solve the one puzzle, does that mean I need to be more difficult on the next one? I don't really know. And as you start adding more and more and more of these devices, they need to communicate with each other to work out what the overall state of the escape room is. And it became really difficult to do. So doing it at each device level was not something that was going to be tenable. What I instead did was I introduced a concept of an escape room run. And this is a state machine, essentially. So the state machine has got a few states. We've got a start and an end state. And when you start the escape room, it is in on-schedule state. So the state is on schedule. The players are going through as they should be along the way. As they solve more and more puzzles, they stay on schedule for a while. Eventually, X number of minutes pass, and they haven't solved enough puzzles. And at this stage, the state transitions into behind schedule. So now I need to do something. I need to react to this. So I publish a message to say, well, now all the puzzles need to decrease the difficulty. And that goes off, and the devices can then change their difficulty along the way. More time passes, more puzzles get solved. Eventually, they go back to on schedule. And if it's too easy for them, they might go ahead of schedule if they solve insufficient puzzles. And this state transition, again, results in a message going out to all the devices to say, you need to be a little bit more difficult so that the players don't fly through the rest of the room. And eventually, all of the various states can either be completed. So they can complete the escape room either on schedule, behind schedule, or ahead of schedule. And ideally, they would finish it on schedule, because that means that they're going to get that 45 to 60-minute sweet spot. But they will eventually finish it. So the escape room run is a state machine, and it's a distributed state machine. And all it does is it tracks the time that has been spent in the escape room. And so it adjusts the difficulty based on how long the players have been in the escape room, and it can completely change the flow of the room. So maybe if they solve one puzzle, instead of opening up, the treasure chest, it'll open up it'll open up the catapult and throw the next clue along, so you can completely skip a puzzle if they need to change the flow completely. And the fun thing here is that the puzzles don't need to know about each other. All of the complexity around keeping track of how the escape room should be flowing is maintained within this state machine, within the escape room run. The devices don't need to know anything about how the room flow has changed. They just need to follow what the difficulty should be for those devices. So the escape room run is sort of like an orchestra conductor. In the .NET space, there's 3 typical ways you can implement these. So you've got the process manager pattern. In .NET, we typically call it sagas. You can also do the actor model, or you can implement the routing slip pattern to be able to do these. But what's really powerful here is that because all of the complexity around the difficulty of the escape room is encapsulated within this one state machine, you can unit test that flow completely, and you can unit test the code that's running on your devices. Now, an orchestral conductor almost definitely can play a lot of the instruments in the orchestra, but they're not physically playing the violin, right? The violinist is sitting there looking at their sheet music or algorithm, and all they need to do is respond to what the conductor tells them. Oh, we need a little more wind. We need a little less on the percussion. Play faster, play slower. They've still got their instruction sheet that they're following, the musical notes that they need to track along with, but they can also respond to what the orchestral conductor is saying. So the aggregate roots remain simple because you've got small aggregate roots, and the devices only need to know what they need to know about their puzzle. They don't need to know what the rest of the room is doing. And you can build really complex flows by encapsulating a state machine that keeps track of the entire room as a whole, but the devices only need to focus on what they're doing. So the complexity is encapsulated in one place, and you can test it, and you can also unit test the actual puzzle code itself. Some examples, if we go back to our claim service. So as a claim request comes in, our claim capture service will publish a message and say, hey, the claim process has been started. That goes to perhaps the assessor feedback service, and it goes to our saga, or our state machine. And the saga, in this case, keeps track of the state and says, well, we've started the claim process, but I don't know whether it's approved or not. I need to get feedback from the assessor. So the assessor would go and look at the car and say, okay, well, now I've captured this. Yes, it's valid, or no, it's not valid in terms of claims. That goes to the saga again, and now the saga says, right, I have enough information from these various small parts of the system to make a decision about whether or not the claim should be honored or rejected. So it can then send out a message at that point. So in this case, all of the various parts that are involved in this claims process, they only need to know about their little bit. So the assessor only needs to know whether or not the car crash is valid or not. The finance system only needs to send a message to say, yes, the payments have been made and we need to honor this claim. So each of the systems only focuses on their small thing. The state machine keeps track of all of the pieces together and eventually sends whether or not the claim has been approved or denied. So they've got all of these devices, and they're communicating with each other, but they're also communicating with an escape room run, which in this case was an implementation of the saga pattern. Now let's take a look at working around the limitations of these devices. So like I said, MQTT is not actually a queue, and it's got a slightly smaller feature set. Some of the features that it doesn't have that I really wish that it did have was the ability to send delayed delivery messages, or messages in the future. That's where you say, well, I want this message to be sent in 5 minutes' time. Really useful if you're doing a time-based escape room, right? But MQTT doesn't support that. It also doesn't have a time to be received. So if you send a message, but that message has expired, it should be discarded rather than honored when it gets to the front. So MQTT doesn't have that. And the biggest one is that you can't queue messages up because it's not a queue. And depending on the implementation that you've chosen, it can be surprisingly difficult to monitor MQTT. Some of them are more easy to monitor than others, which is a little bit odd. But how can we work around this? So if we've got our devices and they're talking MQTT, the state machine that is keeping track of the flow of the escape room, that needs to be able to send messages in the future. It needs to be able to process messages that are in a queue. I can't afford to lose messages. So what I would have actually liked is if I had MQTT for the devices, it sure would be nice if I could use a real broker to actually talk with my systems, the part that's interacting with the way the room flows. And thankfully, we can do that because there's patterns for it. So the pattern that I ended up using is called the messaging bridge pattern. And the messaging bridge pattern is a way of being able to take different queuing technologies and have them work together. So if I wanted to add an additional service later on, maybe something that keeps track of the analytics of the catapult, how many times the children have screamed every time a catapult launches, I can add that to RabbitMQ, because that's where I want to process all of these important messages, and the message bridge pattern will take care of making sure that I get notified whenever the catapult launches puzzles. So the way it does this is logically it replaces all of your physical queues with a logical entity of the queue. So instead of having an actual sword puzzle, it would be there's a logical queue called sword, there's a logical treasure chest. All of these are replaced with logical instances of whatever you're working with. The same on the other side, where you've got a more fully featured broker. And then the transports, instead of having MQTT and RabbitMQ, are again replaced just with logical versions of the transport. So transport 1 and transport 2, which means that if a message needs to go to swords, it doesn't need to know, well, I need to convert it from this format into this format. I just know that swords, there's a sword subscriber connected to transport 1, and I know how to translate from my current message type into transport 1. So we can send the message to the right location. It also means if we add an additional instance of that in the future, the bridge then knows, well, okay, I need to send it to transport 1 and transport 2 because there's a new version that's sitting on transport 2. This is all transparent to your actual code. The messaging bridge takes care of making sure that everything gets routed to where it needs to go. And in an escape room, this is great because I can send multiple copies of messages across different transports. But this is even more powerful than that. So if you are doing legacy systems, so maybe you've got a system that's running on MSMQ. First of all, my condolences. Second of all, it's not the end of the world. Because if you implement an instance of the messaging bridge pattern, you can add new functionality using new technology, SQS for instance, maybe you're deploying on Lambda, and the messaging bridge will make sure that all the messages that need to go to MSMQ and all the messages that come from MSMQ and that have to go to SQS get routed to the correct locations. So it's a really powerful way to be able to modernize existing legacy systems without having to do a whole big rewrite. Eventually, you can start taking some of those old endpoints and moving them over to a new cloud-native approach. They don't need to know that it's moved. Everything is taken care of by the implementation of the bridge pattern. It is a super powerful technique, and it can be used in many different ways. Highly recommend spending some time to take a look at it. So working around the limitations, by using the messaging bridge pattern, I was able to start using a more fully fledged broker for the dashboard monitoring section of my application. But the devices that were using MQTT could still use MQTT because it was applicable for them. It was appropriate. MQTT is a good fit for these low-power devices. How did the escape room go? Well, not great, if I'm honest. So here's a picture of me. I am busy assembling the little balance puzzle. This is about the 4th or 5th iteration of it at this stage. I was convinced that I had it correct here. That's why I'm using a new strip of LEDs. It was only a few minutes after this picture was taken that I realized I forgot to include the holes for the connections to go through to the underside. So we had another iteration of this. The musical tone puzzle was a real pain to make because I wanted a really small form factor instead of this giant thing that looks like I should pull an aerial out every time I want to use it. But I couldn't get the parts to be strong enough on the size of the form factor that I wanted. It was horrible. I am also incredibly clumsy. This is a photo. You'll notice that there's censored parts there where I cut myself. I wonder which puzzle this was with. But you'll notice that there's already plasters on my finger. So this was not the first time this day that I had managed to cut myself. I'm terrible at soldering. So here is, I was busy assembling the Simon Says puzzles. You'll notice that these two need to go through those two holes, right? Except, wow, they're already connected. That was not very smart. I should not actually be allowed near a soldering iron. I burnt my fingers multiple times. I melted the cable of the soldering iron with the soldering iron. Does anybody have like a really fancy mechanical keyboard? You might want to like block your ears for this part because there are now 3 little holes that have melted into my keyboard as well with my soldering iron. But eventually I had all of this done and I was convinced now this is going to be great. And I had the feeling like, you know, if I built the Colosseum, I was the architect of that, and I'm going to have these gladiators come through, and they're going to do this amazing thing and have the time of their lives. Or like, because it's children, has anybody seen the Goonies? Right? It's an adventure that these kids go through, and they have difficult times, but they come together at the end, and they've got stronger friendships. I didn't get the gladiators or the Goonies. I got gremlins. Absolutely everything broke. It took about 5 or 6 different times of trying to get this escape room to work before I finally had it working. In fact, this is a picture taken, I think it was about the 4th time that I tried to get it working. My dog is very happy that I'm sitting there with him. I was feeling completely sorry for myself at this stage. It was not a great day. Because, you know, you invite all these children around, you build this game up for them, they're going to have the most amazing time, and then nothing works, and you look like an idiot. In fact, one of my daughter's friends, she came up to me after this photo was taken, and she's absolutely tiny. She's like minute. But she's such a sweetheart. Like, children are like sweet. They were very kind. And as we grow up into adults, we sort of beat that kindness out of ourselves. So she comes up to me and she puts her arm on my shoulder, which while I was sitting there, it's probably about the same height anyway. And she looks at me and says, maybe you should have tried harder. And it took a while for the kindness to stop stinging, but eventually I got over it, and I did try harder. Like, a lot of these mistakes were just silly things, like I've set it up at their friend's house, and they didn't have internet access. Like, stupid things like that weren't working, but eventually we managed to get the escape room working, and the kids had an absolute blast. So it took them a few a few attempts to get through some of the puzzles. Yes, some more of the analog ones that they did, because we've gone through some of the more digital ones. But eventually they managed to get the escape room solved. They released the cake from inside the last chest. It took them about 70 minutes, so I could have been a little more aggressive on the changing the difficulty down. But they all had a great time. I've now run this escape room multiple times for different age groups, and I've tweaked the aggressiveness of how quickly I change the difficulty, and now most people, when I run it, seem to finish it somewhere between about 55 minutes. So I've got a lot of use out of this as well. The things I'll remember from this experience is, even if I'm just doing low-level device stuff, it's important to think about what I'm monitoring. I need to be intentional with the type of monitoring that I'm doing of these systems. Spending some time thinking about what the service boundaries are within my system means that I can make those service boundaries as small as possible, which makes it easier to maintain in the future because I can change a lot of it. By distributing the state, I was able to keep simplicity in the actual devices while keeping simplicity in the overall flow. So having the state machine be a distributed state machine meant that I could keep that simplicity in the places where it belonged or where it was appropriate. And polyglot messaging, I mean, the messaging bridge pattern has been one of my favorite for a long time now, but this just it reminded me why the messaging bridge pattern can be so powerful, especially for things like legacy system modernization. It's super valuable. But I think the thing that I remember the most is the experiences that are unlocked for my daughters. So on the right here, there's my daughter looking at a corona telescope, which is to see the sun. So what happened is one of the puzzles had a little magnifying glass in it, and from there, magnifying glasses amazed her, and then she got into binoculars, and now I have to take her to stargazing camps because she's absolutely enthralled with anything that has optic lenses. My daughter on the left is busy making an escape room for me at my parents' house while we were on holiday. So she's now enamored with these, and hopefully when she's a little bit older, we can start doing other escape rooms together, assuming that they opened up more in Johannesburg, because I've done them all. But ultimately, the experience that was created for my children was more than the amount of work of the individual puzzles. And I think as software developers, we think about tickets that we're moving across. Now it's accepted, done, cool, happy, great. But there's so much more that we do for people and for systems that we don't necessarily think about. So as you go through the rest of the conference, don't just think about the cool technology that you see or the techniques that people talk about. Maybe also spend some time thinking about, well, what is the second level effect that I can enable by using this technology? Thank you. I do have time for questions, but if you don't want to chat to me, I'm also just going to be at the particular booth after this. So if there are any questions, you're welcome to come and speak to me about that as well. Thank you very much.